Hey guys, welcome to my YouTube channel. So this is one of the gates question. I think it may be 2014 or 2016. I'm not sure. So this is one of the gate question that they ask that the question states that they have given some graph over which they are given some profile of holes concentration across the distance x. So this is nothing but the semiconductor region only. So here you can consider there is one semiconductor is lying and that concentration gradient is given like this. So question states that the steady state holes concentration in the semiconductor is as shown below. With the dp, they given one constant value also, that is diffusivity or diffusion coefficient. So find the diffusion current density of the holes from the region 0 to 2 micrometer. So they clearly given all the information, and also they stated another one clue word. They asked you to find only the diffusion current, not drift. So the from in the region that 0 to 2 microamps, the change in the profile of dp, the holes, is not equal to 0. Means the diffusion current will also be not equal to 0. So this is not equal to 0. So then there will be diffusion current. So jp, which is equal to minus q dp by dx. So which is nothing but a difference in potential or difference in some value. So they have asked us the density only. So jp is finding itself will be fine. So let me write the expansion for this. So q value, which will be equal to 1.6 into 10 power minus 19, as we know that. So dp, the question itself they stated, and which is in centimeter. So we have to note the term that they given is centimeter, but here it is in meter. So we have to convert this into centimeter or other thing into some, all the things need to be in the same term. So let's convert the meter into centimeter. Okay, so let's see how it is coming. So let's keep the 25 as it is, and here we have to check the difference in dp by dx. So how we can check the dp by dx is that from this potential, from this point, the higher point to lower point. So this way we can say, so dy by dx, so that is what the value, so dp by dx. So 2 into 10 power 8, so that is a higher value, minus 1 into 10 power 8, so divided by 0 minus 2 micrometer, so that can be converted into centimeter by adding this one. So 10 power minus 4 from the meter to centimeter. So we have added 100 and multiplied by 100 over there. So that will become 2 into 10 power minus 4. So then we substitute, we calculate all this formula. Then we will get 1.9 into 25, 1.6 into 25 into 10 power minus 19 into, so this one will be same. So 10 power 8, if we take outside, then that will be 1 into 10 power 8. From the divided by, we can take this minus 4 into plus. So then that will become 10 power 12 divided by minus 2. Okay, so then we can cancel out these negative terms and we can simplify it into 0.8 into 25 into 10 power minus 7. Okay, so if we multiply 0.8 into 25, then the value will be 100 to 200 will be there. So it will be 0.8. So this is 20. So 20 into 10 power minus 7. So this is the value. So based on the option that they provided, you can find out the answer. Okay. So let me ask you another question. So let me get into so let's consider this as a part A. So in part B, so this is the part B. So part A we have solved here. That is what this. In part B, find the JP. What will be the diffusion current JP? What will be the JP at the region above or x greater than 2 micrometer? Sorry, 2 micrometer. X greater than 2 micrometer. So this is the part B. So we please pause the video here and try to answer and put the answers in the comment section. So it will be good to know if you guys able to answer it correctly. So if you pause the video and put the answer, let me solve the answer for this. So let's take the part B. When x is taken greater than 2 micrometer, we know that the profile dp by dx, which is equal to 0. So then ultimately this will equal to the JP diffusion current, which is equal to 0, because there is no change in the slope or change in direction. So here there is a constant doping. So then there will be no change in concentration or gradient of concentration. So that's why the diffusion current will be 0 for this one. So I hope you guys able to get this answer. So if you guys have any doubt, please ping in the comment section. So here you see there is nothing, just the formula and application. That is what they ask. So this is one of the gate question they asked. So you can easily get a 2 or 1 marks based on it. If it is IES, you can able to clear it very easily. So this is how the questions will be. So here there is a direct substitution. In most of the case, there will be some tricky details will be given in the diagram or in the theory that they asked. So once you guys able to get the here you know the concept like how the diffusion works. So here you can easily apply it. So even if there is any tricky part there, you can able to answer it. So that is what. So we have to be understanding the theory very carefully first. Then we are going to apply that in a formula. That's what the simple thing. So college engineering studies every subject, not only this electronic devices, network theory, control system, communication systems, everything is like this only. Just a application of what we are studying. So that we have to apply that in a real world problem or any kind of real world scenarios. We have to practically understand how things is working. So then only you will become a good engineer. So like instead of studying and writing what we are learn what we are studied, let's just try to understand it conceptually. Then your engineering will be very good and it will be very understanding and you will love to learn it. So we have to practically we have to know how to implement and how to understand it. So that is what the lack of skill many engineers are having nowadays. So please practically study, don't mug up and those things. Let's try to, if there is many GPTs, AI models are also there. Just to keep on asking question and improve your skills, then that will be very much good for you guys to understand. So like understanding things is matter. So let's go over it. So I will be giving you the practical understanding, basic understanding I will be producing you. So still now I think you're able to get the, we are in the same phase I think. So even if you have any suggestion or comment, please ping in the comment section. I will be able to rectify it. So I hope you guys able to understand this problem. So from next lecture, let's get deeper dive into like Fermi levels and other things. Fermi levels and charge carrier densities, which is some interesting topic. So I will be making you to understand in a many practical way, because while I was studying in a college, I was lagged in those things. I was not able to understand that in proper way. So I hope you guys can able to understand by watching these videos. So stay tuned for the next upcoming lectures. Thank you.